Hello everybody, welcome back to Mathlings. Today we're going to be looking at gradients of straight lines, including conditions for them to be either parallel or perpendicular, and this is, as you can see, either on C1 if you're on AQA, and we're doing this sentence here, gradient conditions for two straight lines to be parallel or perpendicular, or for EdXL, it is the second paragraph here. And then we're going to be looking at that in more detail. Just as a reminder, the gradient is the slope or the steepness of a straight line. So you can either have a positive or a negative gradient. This one here is positive. A line going in this direction would have a negative gradient. The equation of a straight line, as we all know, is y equals mx plus c. And this letter m here represents the gradient. If you want more information on that, in the previous video I went into more detail about straight line equations in general, so you can learn a bit more there. But if you are familiar with what the gradient is, then let's move on to the next part. Just going to quickly jot that down so it's on the screen for us. So the gradient is the slope or steepness of a line. Let's say we've got 2 points. These are just random ones, they can be any points. Let's call this one A with the coordinates x, A and y, A. And this coordinate, let's call it B with coordinates x, B and y, B. So as I said, these can be any coordinates, these x, y's can be any points, but just for our example, I've just plotted them here on the axis. Like I said, they can be anywhere. And say there was a line joining these 2 points together and we wanted to find that line's gradient. We usually denote the gradient by the letter m, and the formula for finding the gradient of a line joining point A to point B is as follows. So it's ya, which is the y coordinate of the point A, minus yb, which is the y coordinate of point B, divided by xa from here, x coordinate of the point A, minus xb, which is from here. This formula works for any 2 points in the xy plane where you're trying to find the gradient of a straight line which is joining the two together. So what you're doing is subtracting the two y coordinates from each other and then dividing that by the difference between the two x coordinates. We'll see this a little bit later on in practice, but often exam questions ask you maybe to find the equation of a line given 2 points, or maybe the equation of a parallel line or a perpendicular line. And you can use this little formula here to find the gradient, which is often required as part of those questions. So as I just said, one of the things we need to be learning is about parallel lines, what that means, and the conditions for two lines to be parallel to each other. Lines are parallel if they have the exact same gradient. So these two lines run side by side like train tracks. They're never going to be able to cross because they are pointing at the exact same angle in the exact same direction. So let's call this line 1 and call this line 2. We'll write the equations as well. So y equals mx plus c is our general equation of a line, but we're going to call this m1 x plus c1, and y equals m2 x plus c2, just to be able to tell the difference between the two. Now, parallel lines have the same gradient. Now, if you remember, the letter m represents the gradient. So because the lines L1 and L2 are parallel, we know that the gradients have got to be the same. So M1 and M2 are equal. And this is something very useful and very important to remember and learn. It's a nice simple one to remember so that when two lines are parallel, their gradients are equal. And then finally we move on to perpendicular lines. Instead of running in the exact same direction like parallel lines would, they instead run almost in opposite directions. And what that means is the angle at the point where the two lines intersect is a right angle. It's 90 degrees. So now let's label these two lines. We'll have L1 and L2 and have a look at the conditions for two lines to be perpendicular. Again, let's give them equations. So this is y equals m1 x plus c1, and this is y equals m2x plus c2. Similar to before, but this time m1 and m2 aren't equal, they're supposedly opposite, and that actually means that if you times them together you get -1. So that is the major condition you need to know for perpendicular lines. Just rearranging that, so we've got another way of looking at it. We can have m1 equals minus 1 over m2. So if you've been told that two lines are perpendicular, then the gradient of one of the lines is the negative reciprocal of the gradient of the other. Moving on to some example questions, I'm just going to write the three formulae we've learned in this corner so we have them for reference. So we've got the formulae for finding the gradient, which is m equals ya minus yb over xa minus xb. We've got the condition for two lines to be parallel, which is m1 equals m2. And we've got the condition for them to be perpendicular, which is m1 equals minus 1 over m2, or m1 times m2 equals minus 1. Let's work through a couple of these questions. So the first one says the line AB passes through the point A, minus 1, 9, and the point B, 2, 12. Find the gradient of the line. Simply here we can plug in our values into the formula to find the gradient. So let's do that. M equals ya, 9, minus yb, 12, over xa, or the x-coordinate of a, minus 1, minus xb, the x-coordinate of b, 12. Now let's simplify that. So that's minus 3 over minus 13, which is simply 3 over 13. The next question uses this answer. So it says the line L is parallel to the line AB and passes through the point C, 1 minus 4. What is the equation of the line? Give your answer in the form y equals mx plus c. We know that the condition for something to be parallel is that the gradients are the same. So the gradient of AB, let's call it MAB, is 3 over 13. The line L is parallel to the line AB, so ML equals MAB as L is parallel to AB. This is just a quick shorthand notation for parallel. So ML is also 3 over 13. So that's our gradient found. Now we just need to plug in some values and find the actual equation. So if you remember from last video, y minus y1 equals mx minus x1 is a general equation of the line where x1 and y1 are coordinates of a point on the line, which coincidentally we do have. So let's plug those values in and see what we get. So y minus minus 4, so that's going to be plus 4, equals m, our value for m is 3 over 13, bracket x minus x1 is 1. That is the equation of the line, but we want it in the form y equals mx plus c. So we want y on one side, everything else on the other side. We end up with y equals 3x over 13 minus 3 over 13 minus 4, which equals 3 over 13x minus 55 over 13. The final question is asking us to verify that two lines are perpendicular, which means that they have a right angle between them. And if you remember, the condition for two lines to be perpendicular is m1 times m2 equals minus 1. So if you're multiplying the two gradients, let's say this is equation 1 and this is equation 2. If we multiply the two gradients together and it equals minus 1, that means that the two lines are perpendicular. So let's find the gradient of each line. Line 1 is in the form y equals mx plus c, so we can simply pull that m value, or in this case m1 value, out. It's the value in front of the x, which is 3. The value for m2, or the gradient of line 2, is a bit trickier because it's not in a form that we can just pull it out, so we're going to need to rearrange it. So let's do that over here. We want the y values on one side and everything else on the other. Divide that by 3, so y equals minus a third x minus 8. And that means we have this value here, which is our gradient, which is m2. So m2 is minus a third. Now let's multiply these and see if we come out with minus 1. If we do, then the two lines are perpendicular. 3 times minus 1 over 3 equals minus 3 over 3 or minus 1. So L1 and L2 are perpendicular. And there we have it. So the three things that we need to take away from this video is, first of all, the equation for finding the gradient, which is finding the difference between the y values and dividing that by the difference in the x values. The condition for two lines to be parallel is that their gradients are the same, so m1 equals m2, and for them to be perpendicular, they multiply to make minus 1.